Right. So, here's the problem. Z is not always going to be average 0, standard deviation 1. I'll give you an example. Maybe we're looking at students' heights, H. And the height has a normal distribution of, let's say, 150 centimeters, and here we could say is 25 centimeters. Now the meaning is that this is the mean, the average, okay? And this is actually called the variance, is the real name for it. And the meaning is, if you take the square root of this, you get the standard deviation, which is 5 centimeters. I know that seems a bit weird. We won't go into the reasons for that. But what you do is you take the square root of this number. It's just the way we write it. So, on the graph, what you have is this. The average is 150, and the standard deviation is 5. Okay? That means most people are between 145 and 155. Is everybody between 145 and 155? No, just most people are. Okay? So here's the problem. Say I ask you, okay, how many people are less than 160? Well, we have a problem because this table here is only for the situation when this is 0.
Yes.
It's not for this situation. So we have this trick which we call the Z transform. And we can take this and change it into one of these. And the rule to change it is this. The Z equals the X, or in this case I was using H. I'll change this to X to keep it the same. X. This is X. Z equals X minus the average over the standard deviation. So this here becomes 0, and then this is 1 and 1. So what is 150 and 160 down here? Oh, sorry, not 150. I know 150 is the center. 0. What is 160? So we do Z equals 160 minus 150, yeah, over 5. Which equals 2. So this is a 2. So this answer here will be table book value 2. And it's using this Z transform. This is the name of the rule, the Z transform. And this here is called the Z score.
But I would really need this, or we always have the number like small if we have the question like 5 to 5.
Yeah.
Like unit, we can change to 1, and we can see there's 2. You got what I mean? Like.
Oh yeah, I see what you're saying. That these are 5s.
Yeah, it's like 1 unit.
It's exactly that, and that's called the Z score. So what you're saying, Gao, is we can see the 160 is what you said is 2 units, but we don't call it 2 units. We call it Z score of 2. So yeah, I see what you're saying. That it's like a 5 and a 5. Yeah, it's the same as that. Yeah.
Your face have a shining point.
Does it? Where?
Here. No, here. Left.
Gone?
Maybe.
A shining point?
Yeah.
I'm shining? Wow. Amazing.
Yeah.
Okay. Yeah, I know, it's so strange. It's very, it's very complicated.
But you say the sigma just
The
the
one,
uncertainty.
yeah, but
Here, why we use
the problem is, I said in the last lesson, when you have n01, I said that it's root 1, but it was easy to forget about that because 1 and root 1 are the same.
Yeah.
So it didn't matter. But what I'm saying is, we have this word Ben, variance. And the meaning of variance is uncertainty squared. And that's the number that they use here. So this is why I need to take the root. Guys, you might want to write that down because they do that in the exam sometimes. They would say something like, if the variance is 25, what is the standard deviation?
The U square.
Yeah. Yeah?
Very strange.
Yeah. It has a special meaning that we don't care about right now. Yeah? Yeah?
So this and this is 1.
In this after Z transform.
But you say the average, the area is 1.
Yeah, it's true, the total area.
But this and this is
Oh no, that's not the area.
what's
I'm just saying that most of the time it's between -1 and 1.
oh.
Yeah. Let's do another example. So, in your lab report, remember you calculate something like voltage. So, for example, your first measurement could have been, maybe it was like V minimum is 5 volts, and V maximum it was like 5.2 volts. You remember this? So then you said V is 5.1 volts. And then you had the uncertainty of V, which we said was, what was the formula? It was 5.2. What was it? We could read two numbers, could we? It's like 5.20, wasn't it? Yeah, so it's 5.205 minus 4.995 over 2. That was the uncertainty. The maximum minus the minimum. Yeah? Do you remember doing this in class? If you don't, that's okay. Because I think you did it already in your report when you made... Remember when you made the table?
Yeah, the B2, B3 maximum.
Yeah.
That's mid.
0.105 volts. So what you're saying when you say that is, for the first measurement, the average is 5.1, and most of the time, but not all of the time, the answer will be between 5.1 plus 0.105 and minus 0.105. So when Ben does it and then when Gao does it, they'll get different answers. So maybe, for example, Ben gets 5.1. Maybe Gao gets an answer here. Maybe Summer gets an answer here. Khalifa gets an answer here. Okay? So I would like to know, what is the probability that the answer some new student gets will be more than 5.3? So I want this. Okay, let's calculate it. So, the problem is we need to transform it.
Yes. 5.3 millimeters.
So this is 0 now. And this is not 5.3 as you said, it's 5.3 minus 5.1 over 0.105. So what's that? Khalifa, you have the calculator handy there, so. Yeah? What you get? 1.9047. Yeah? So, what we need to do is look up 1 minus, because it's to the right. 1.90. What's that?
1.9 is 0.9713.
Is this it? No. 8. Sorry? Did I do that right in my head? No. 2. Now it's right, yeah?
Yep.
Yeah. Okay. So this P here is, so what you could say is about 3% of the time the voltage from the first reading will be more than or equal to 5.3 volts. About 3% of the time.
Oh.
Mm-hmm.
Yeah?
Yes.
You see, it's useful.
Yes.
It's useful.
What is the timing?
What I mean is, if we do this 100 times,
Oh,
then about 3 of them,
you like percent.
like a percentage, yeah. Yeah. Did you get this? So also, Gao, you could probably roughly see here in the picture that the Z-score, like, is roughly 2, isn't it? Because this is about 0.1 and this is about 2 of them. So the answer is roughly the same. It's the same as the last one, except in the last one we were looking to the left,
Yeah.
whereas in this one it's the opposite. We're looking to the right. Yeah. So you were asking me somewhere, what do we do if the mean is not 0 and the standard deviation is not 1? And the answer is we transform it back to a 0. That's the trick. Yeah. Is this new or have you seen this before?
Oh.
It's new?
Yeah.
New?
I think maybe just different way, because I see the similar.
Yeah,
thing
because you
before.
knew about the Z score. New or
I
old?
know the shape.
You've seen the shape? Yeah, good. Khalifa? Yeah. You've seen the shape. Yeah, actually I forgot to say that. Does anyone know the name of the shape?
正态分布.
Yes!
Yeah, that's what we learned before.
But in English. Translate it into English. No, in your head. What did you say it is in Chinese? First word.
Positive.
Good. Next word. What was the second word? What's the second Chinese word?
So difficult.
No, say it in Chinese. What is it?
Tai.
Okay, what's that in English?
It's like your state, your.
Okay, fine. Okay, next word.
No, it's calculated. You can't just one by one. It's
No, give me one by one. I want to know one by one. What's the next one?
like surprise.
Surprise. Good. Okay. Positive state surprise. Okay, go.
No, surprise. Separate.
Oh, separate. Okay. No dictionary. Next word.
Cloth.
Okay.
If you put them together, it's like they are in different position. That's the last two words together.
And
Okay,
translate.
translate.
Okay. Before you tell me what it is, I'll tell you what it is in English, and you can tell me if it's the same in Chinese when you translate it. So we call this this shape here the bell curve. Now, what is the translation from Chinese?
Our title.
What?
The title, normal distribution. Normal distribution.
Yeah, but that's the name of the whole lesson. I just want the name of the shape. The name of the shape. Maybe you don't have a name in Chinese, but this has a name. It's called the bell curve. Now, maybe you can see why. What's this word in English?
Bell.
Yeah. Ding, 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 ding.
That's this way.
No, that's belt.
Belt, yeah.
You know, bell. You ring the bell. It looks like this. Ah, you know this. Look. And you ring it. Ding, 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 ding. You know this?
I know.
Yeah, so this is called the bell curve because it looks like a bell. Yeah, jingle bells, yes.
We just call it the diagram of normal
Oh, that's
distribution.
not. Oh, that's a terrible name. That's a terrible name. The diagram of normal distribution. Nah, this is better. The bell curve.
Oh, maybe I say the word is the title, not the shape. But I know this lesson.
Yeah, well, Gao said in Chinese the name of the shape is just the diagram of the normal distribution.
Maybe means
Can you? I'm just wondering. Could you translate this into Chinese and just see if you recognize it? So type the bell curve and see what it is in Chinese. What? What?
I think I forgot a lot of things.
I don't know.
You translate it
Yeah.
and it doesn't mean anything in Chinese?
It sounds really academic, but I never seen it.
Oh, okay. Oh, okay. Because the reason I'm telling you this is in English, we can use this in day-to-day life. I'll give you an example. Okay, so that's okay. You can put the phone down now. Like a it's belt, yeah. I'll give you an example. So you could say, if you said something like, let's say you could say, Ben is so smart. Okay. He is at the end, no, sorry, the tail of the bell curve. Guys, come on, look at me, please. Put the phone down for a second. Turn it over. Thank you. Do you not agree with me? Ben is so smart. Agree? Okay, good. He is at the tail of the bell curve. So the tail of the bell curve is here or here. It means it's unlikely. Do you know what I mean? Because if we remember back here, this part here was only 3%.
But you say it's positive or negative. But
Yeah.
Negative you say is
That means
end,
Ben is really stupid.
which is end.
Which end?
Is
Here,
the top?
no, here it means boat, but because I said this, it means I'm talking here. But if I said Ben is so stupid, he is at the tail of the bell curve, then it must mean I'm talking about him being here.
Also is top.
Its tail is boat. Yeah. Do you have? I'm sure you have this in China. IQ. Yeah. So I don't know if you know this, but the way IQ works is like this: that the average is always 100. Yeah.
Yes.
Yeah. And does anyone know what the standard deviation is? Not as much as 20. It's 15.
15 or 50.
See, he wasn't here yesterday, so he didn't learn. Remember, 15 or 50. Ben knows which it is. He learned yesterday.
About,
Which is it,
about
Ben?
50, there have someone still has the less than 50.
I know. That's why we say most,
Okay.
but not all. Most people are between 85 IQ and 115 IQ.
The 85 still big.
No. 85 and 115. Most people are between those two. Okay? So,
So less than 85.
85, less than 85, yeah, I suppose that wouldn't be great. And more than 115, that would be good. And in between the two, that's just normal. Okay? So, what do we think Ben's IQ is?
No, what's her IQ? Do you know?
Counter 50.
No, it's not. The test I did, I think if I remember, was 127. So,
So use yours. So that.
okay. 127. Right, so if we say 127, let's calculate the probability that the IQ is less than 127. Okay, so what do? I change 127. I do 127 minus 100 over 15, and that's going to be 1.9 something, isn't it? 1.8. Okay, so if I look up 1.8, what do I get?
9641.
0.9641, which is 96.41%. So that means if you have this, you are smarter than 96% of people. Okay? Now, most of you, because you're going to college, you will have a similar score. I would think most of you, if you did a test, I would think most of you would be between 115 and 130.
130?
Which is the highest IQ?
I'm not sure what the highest is.
Maybe it's
Not sure. But just look, if you go on to university, it'd be between 115 and 130. People who don't go to university, maybe they're between 100 and, so this is just like high school, 100 and 115. People who don't finish high school, if you don't finish high school, then it's less, you're probably less than 100.
So education can change the.
No, it's the other way. The IQ makes you do more education, not.
Oh yeah.
Yeah, no, I understand that, yeah. So, like, more IQ means more education. It's this way, not this way. Sadly.
So how about master?
Yeah, masters would be, I'd say, at the up end here. And the people with the highest IQ, guys, come on, I'm talking to you. Don't be rude. The people with the highest IQ are people who study medicine. Okay, so if you look at every department at university, like IT, biology, business, if you look at them all, people who want to be doctors, medicine, they have the highest IQ, this group, medicine. Perhaps, I don't know. I'm not sure what the lowest is. Yeah.
55. I just searched.
Is 55 the lowest?
It's like less than 55, only 0.1%.
Yeah.
And the highest is kind of 145.
Yeah. If your IQ is very low, then that means like you have like special problems. You know what I mean? Yeah.
Of course. No.
Yeah. And this is important because then, you know, maybe you can get help or something like this. Okay, so not too difficult. I will like you to try. You can do question. Question 7, 8,
7, 8.
9, and 14. Now what we'll do, you'll try them for a few minutes and then we'll have a physics.
Yes.
But wait, we'll take a little breakfast break before we do physics, okay? So, did you have breakfast?
Yes.
Oh, good man. All right, did you have breakfast? Did you have
Sorry.
breakfast? Oh, good. Here or at home?
Yeah.
Good start. Khalifa, did you have breakfast? No, the 2 of you did and 2 of you didn't. So just try these until 10:30, and then we'll take a breakfast break.
So here we don't need to use the 4.
In which one?
The 7.
No.
Yeah.
No.
Just give us.
I just gave it to you, yeah.